American astronauts have not flown to space from U.S. soil in nearly 10 years. That is about to change.
I think the United States is a nation of explorers. It's something that fundamentally appeals to our psyche.
This is an experiment to see if an innovative private company such as SpaceX can fly NASA astronauts and reinvigorate space exploration.
It's an honor to be not only representing NASA, but SpaceX as well in this next step of space exploration.
It's a scary thing to be launching people, and the risk is never zero.
Sometimes things do blow up.
Space is hard.
How do you manage telling your son that you're facing that risk as you go forward?
The second golden age
3,
of space travel
2,
begins
1.
now.
T-minus 3, 2, 1, 0, ignition.
We were able to get to the moon in '69, and that was only 66 years from first flight, from Orville and Wilbur Wright's first flight. It was in 1903. It was the first controlled powered flight. Only 66 years later, it's landing on the moon. That's incredible. Even though it was only a few people that did it, vicariously, we all went to the moon. Like, humanity went to the moon. And it was the greatest accomplishment of human civilization. But it's been now 51 years since that first landing. And no one has the ability to land on the moon.
The Apollo era ended in triumph, and NASA looked forward to a bright future with its new program, the Space Shuttle. However, after 30 years, 133 successful missions, and 2 catastrophic disasters,
Obviously a major malfunction.
the Space Shuttle program ended in 2011.
The Space Shuttle pulls into port for the last time.
NASA's days of flying people to space seemed to be over. They relied on Russian Soyuz rockets to get astronauts to the space station.
If you'd asked people in '69, they would have said by 2020, we would have had, hotels on Pluto. They wouldn't have thought that in 2020, that the United States hadn't been able to send people to orbit for 9 years. And so basically, we cannot be complacent about technology development. We have to really drive innovation hard.
Eight years later, the head of NASA, Administrator Jim Bridentstine, has traveled from Washington, D.C. to make an important announcement about the future of space travel.
Hey, good to see you. You doing all right? Yeah. Excellent. Good.
He is joined by Elon Musk, the visionary and at times controversial founder and chief engineer of SpaceX. This announcement is the result of NASA's radical new partnership with the private sector called the Commercial Crew Program.
Thank you for coming to SpaceX today in Hawthorne, California. The highest priority is launching American astronauts on American rockets from American soil. We are on the cusp of making that a reality.
There's a lot of negativity especially these days, and it would be great to have something positive that perhaps can unite the country of the world, and advancement in space is one of those things. That is the reason that SpaceX was created. The launch of Crew is something that we've been working towards for 17 years.
Journalist Christian Davenport, who covers defense and space for the Washington Post, has been on the front lines, reporting on the Commercial Crew Program since its inception in 2010.
This is sort of, in some ways, an experiment to see if NASA can rely on these commercial partners to fly their astronauts safely.
NASA astronauts Doug Hurley and Bob Behnken will be the first to launch on SpaceX's inaugural crewed flight, marking the first time in history that NASA astronauts will fly on privately owned spacecraft.
This first flight with Crew is a test flight. Even the flight itself is a test flight, and it is done with test pilots, work for NASA, who will be evaluating the system itself. And Elon and I are in strong agreement that whatever it takes to make sure they are safe is what we are focused on like a laser.
Before SpaceX can launch Crew, two major milestones must be completed without Crew. The first is the Demonstration 1 mission, or Demo 1, in which SpaceX must autonomously fly their Crew Dragon capsule to the International Space Station and back. The second test is called the Launch Escape Test, also known as the In-Flight Abort Test. If the rocket fails, the Dragon capsule's emergency abort system is triggered, ejecting the capsule safely away from the rocket. Then there is the third and final test, called the Demonstration 2 mission, or Demo 2, which will launch NASA astronauts Bob and Doug to the space station.
When we think about the history of human spaceflight, it's always been government-owned, government-operated systems. So the Commercial Crew Program is our way of commercializing human spaceflight.
Robert Cabana is a former astronaut and the director of the Kennedy Space Center in Cape Canaveral, Florida.
The idea is to not have to own the vehicles. We buy a service. We buy a taxi ride to space to do what we need.
We have two separate vehicles, one SpaceX, one Boeing. When you have multiple providers that are competing against each other, they don't keep coming back to the taxpayer asking for more money. We'd like to have access to space be so low cost that industry is sending workers to space in a way that's going to be transformative for humankind.
When the Commercial Crew Program was first proposed, there were doubts about whether it could work. Many worried that privatization would lead to decreased oversight, accountability, and less revenue for the government.
You know, we really are in another golden age, if you will. It's neat to see, and it's neat to be, you know, maybe what you would argue is the ground floor of that now with Commercial Crew and what we're doing for SpaceX.
Here with the Commercial Crew Program, you've got two new capsules, the Boeing Starliner and the SpaceX Crew Dragon. New technology, new innovation going into them. They're autonomous. They have the ability to fly to the International Space Station, meet up with the space station in orbit, and autonomously dock with it. It's like a self-driving car that can park itself, and that's a new technology that we haven't seen before.
In 2014, NASA's Commercial Crew Program awarded SpaceX a $2.6 billion contract. After nearly a decade of designing and testing their new spacecraft, SpaceX will be the first private company to launch NASA astronauts.
I'm pretty excited about being on the first flight of a new spacecraft, and it's awesome to work with the SpaceX team. You know, it's just a wonderful place to be. I couldn't have dreamed for a greater opportunity than this.
SpaceX is a hugely ambitious company founded by tech entrepreneur Elon Musk in 2002, ultimately with the goal of trying to colonize Mars.
We want the exciting things that we see in sci-fi, in like sci-fi movies and books, we want that to come true one day. We make that stuff real. In fact, I think hardly anyone in the public knows that this is happening. Like, how do we, get this message across? Hey, really cool stuff's happening, tune in.
But for all of the triumphs and all the successes and all the attention that a company like SpaceX gets, they have not flown humans before. That's a huge responsibility. I mean, NASA's astronauts are their pride and joy, they're national heroes, and their lives are being entrusted with these companies. So we're going to see if they can pass that test.
Today's launch marks the beginning of the Crew Dragon Demo 1 mission. This is one of SpaceX's most challenging milestones yet, a 5-day, uncrewed journey to the International Space Station and back.
Before NASA allows Boeing and SpaceX to fly their astronauts, they require the companies to first do a test flight without crews on board the spacecraft. That's to make sure that these companies can get the capsules to the space station and back safely.
The Demonstration 1 mission, or the Demo 1 mission, is an uncrewed flight. We're sending the Dragon autonomously to space station to dock and come home.
We're going to be in firing room 4 for the launch itself, listening along with the team and kind of keying on the things that would be relatively important to us.
It really is our chance to not be on board, but to be with the rest of the team that'll support us when we actually fly this vehicle when Demo 2 comes around.
This is the first flight of SpaceX's new Crew Dragon capsule, which will one day carry astronauts. It sits atop the SpaceX Falcon 9 rocket. It's 16 feet tall, 13 feet in diameter, and can carry up to 7 people. This mission will test all the systems required to keep passengers alive in the vacuum of space.
We spent years designing and testing all of the vehicle systems. That day is really the day that the rubber meets the road. We fly the vehicle, we test the interfaces of the rocket, of the spacecraft, and make sure that it'll work the way we think it's going to work.
I mean, the sheer number of tests that have occurred for Dragon and Falcon is staggering to think about. I mean, cumulatively, it must be tens of thousands of tests of one kind or another.
Everything is riding on the success of this mission. And if it fails, it's back to the drawing board before SpaceX will be allowed to launch NASA astronauts to the International Space Station. One measure of success is how well NASA and SpaceX personnel work together across the country. The Dragon capsule is monitored by SpaceX Mission Control in Hawthorne, California. The International Space Station is supervised by NASA in Houston. And the launch of the Falcon rocket is conducted by SpaceX in Firing Room 4 at Kennedy Space Center in Florida. NASA Administrator Jim Bridentstine waits, along with countless spectators, in anticipation of this historic launch.
What's fascinating is the level of public interest in an uncrewed test flight. I've not seen this since the space shuttles. It's an amazing day.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
A lot of energy in a rocket. You're basically putting enough energy into the spacecraft such that it's equivalent to like a meteor. It's just like it's difficult for people to even comprehend.
Stage 1 throttle bucket.
Power and telemetry nominal.
Being able to watch the Demo 1 mission head up to the International Space Station was pretty exciting for us. Part of it was that we were seeing a test flight that needed to happen before we were going to get our chance to go to space station.
It's a myriad of emotions because you're looking at all the different things that could possibly happen during those missions, and you're excited about seeing it be completed successfully.
The Falcon 9 rocket is composed of two parts, the first stage and the second stage. A rocket sheds weight as it climbs higher. Once the Falcon 9 first stage uses up all of its fuel, it is no longer needed and separates, making the entire system lighter. Then, after the second stage uses up all of its fuel, it also separates, releasing the Dragon capsule into orbit.
Stage separation confirmed.
The Falcon 9 first stage is separating from the Falcon 9 second stage. Once the first stage of Falcon 9 has separated from the second stage, it's done its job. Its primary mission is to get the second stage on its way with Dragon to the space station. We do have a secondary objective for the first stage of the Falcon rocket, which is to come back from orbit and land.
The norm has always been to let the first stage fall back to Earth and crash into the ocean. But SpaceX has invented the first and only reusable orbital class rocket, which can fly itself back to Earth and land, so it can be reused multiple times.
For the first stage, it starts its engines back up. It flips itself around, and the whole first stage is re-entering the Earth's atmosphere and slowly making its way back down for a landing on a drone ship that is out in the Atlantic Ocean.
Landing legs have deployed. And Falcon 9 has landed.
After the first stage separation is complete, the Crew Dragon capsule is propelled into orbit by the second stage.
The second stage is lighting up its engine, and it's taking the Dragon spacecraft into orbit. Once the second stage successfully gets Dragon into the orbit that it is intended to go, it separates Dragon and moves away.
This is a pivotal moment. The separation of the second stage from the Dragon capsule is the final step of the launch sequence.
Dragon, separation confirmed.
The Crew Dragon is now on track to dock to the International Space Station.
It's amazing. This is a game changer. Now, I want to be clear, this is the beginning. This is the first quarter of a long football game that's five days long. I'm not going to be overexcited at this point. 5 more days.
Even though Dragon is able to autonomously fly, there actually was somebody inside the capsule, and it's basically what you call an anthropomorphic test device.
The passenger for this uncrewed launch is named Ripley. She is equipped and wired with sensors that are going to tell us about her experience. So during launch, she's going to experience different G-forces, and we want to make sure those are safe for future crewed missions. And we've done a lot to predict what that's going to be like, and we want to be 100% sure that our predictions are consistent with the flight that she is going on. What really matters is the direction that those Gs are going through your body. We try to put all the Gs through the chest because they can tolerate a lot more. So if you're dropping, sort of like bungee jumping, it could be going up and down your head. That's not as good as if it's going straight through your chest and you're accelerating in a car.
Rendezvous is the complex ballet where a spacecraft goes from where the launch vehicle leaves it in space to docking to the International Space Station.
Robert Dempsey is one of NASA's flight directors for the International Space Station. He works with teams responsible for this phase of the mission, called rendezvous and docking.
The launch vehicle places it in orbit. That's low Earth orbit. It's actually fairly below and behind the International Space Station. And it'll perform a number of burns or maneuvers where it'll catch up to the space station. And you can think of rendezvous as kind of like a case where a police officer, for example, is sitting by the side of the road and a speeding car comes zooming by it. And what he will do is the police officer will then go from 0 and immediately start to accelerate towards that car. And it's got to match that speed. And eventually, when it catches up to it, it's got to slow down. Now, if it goes too fast, it's going to go past the speeder. If it doesn't go fast enough, it'll eventually not be able to catch that speeder. So it's the same sort of process. This is a fairly critical operation because this is the first time this vehicle has ever flown, and we want to make sure it does not collide with the space station.
A little over 24 hours after launch, SpaceX's Crew Dragon capsule autonomously flies itself to the International Space Station. Now begins the critical docking procedure. It requires meticulous communication between SpaceX Mission Control in Hawthorne, California, NASA Mission Control at Johnson Space Center in Houston, Texas, as well as the International Space Station.
This is the first time that a commercial vehicle will dock to the space station. It's also the first use of the International Docking Adapter, which is the port on space station where commercial vehicles are going to come up and dock. And so we'll see both sides get used for the first time.
The station is ready for approach. And we copy.
The Crew Dragon spacecraft uses an automated system that is able to sense the position of the space station relative to the capsule and is able to guide the capsule into dock with station.
Ultimately, the vehicle is fundamentally flying itself, but we also have ground control who's monitoring it and sending up a certain amount of commands. There's also a certain amount of access that people on the space station, they can see what's happening on Dragon and are in contact with the ground control at the same time.
Monitor Dragon approach. Orientation is expected. Vehicles in the corridor performing review.
At this point in time, we actually take a little pause. We stop within about 20 meters of the docking port that's on the International Space Station.
Hold command sent. Copy hold. Dragon hold confirmed.
And then the engineers at both NASA and SpaceX review the data from the spacecraft. They talk, they make sure that everything is going according to plan, and they're both happy.
Please command the docking light to on. Copy, commanding docking light on.
Then Dragon is allowed at that point to autonomously move forward with the approach and docking to the space station.
Dragon is resuming approach. Station copies.
The Crew Dragon spacecraft uses its 16 Draco thrusters to maneuver into contact with the space station docking adapter.
Range is decreasing. Vehicle is centered. Copy.
The capsule inches in towards the station.
Vehicles in the corridor. Orientation as expected. Copy.
The mood inside Mission Control for a first-time docking of a new vehicle is always a bit stressful. Now, we've spent years planning and training and preparing for it, but space has always had a way of showing us things can surprise us.
Crew Dragon has a variety of safeties in place so that should anything go off nominal, the capsule will automatically retreat and keep the station safe.
All video and overlays look nominal. All status fields are showing expected status. And we copy. Dragon is go for docking.
This is the first ever attempt by the Crew Dragon to track the ISS and move in for what must be a perfect airtight lock.
If everything goes perfectly as expected, we'll just be monitoring, making sure everything goes right.
Dragon is resuming approach and is go for docking. The station crew is ready for docking.
This is the first time that a commercial vehicle has autonomously docked to the space station.
Vehicle mode is approach to docking port. Primary range is decreasing. Vehicle is centered. Top capture confirmed. Mission compares.
Watching the Demo 1 vehicle dock with the space station was amazing. It was kind of terrifying, and it should be. These are the first time you do something, you should be pretty worried about how it's going to go. And it was amazing.
Proceeding to opening the hatch.
On behalf of Ripley, Little Earth, myself, and our crew, welcome to the Crew Dragon. Welcome to the new era in spaceflight.
During the uncrewed mission, Dragon stayed docked with the space station for 5 days. That was to allow the team on the ground to observe and monitor the vehicle performance, and for the crew aboard the International Space Station to work with the vehicle and understand how it was going to interact with the space station.
Now that testing of the Dragon is complete, it's time for it to undock and return to Earth.
At that point, the International Space Station crew, they reversed the steps that they went through when Dragon arrived. So that means they close the hatch on Dragon first, and then they close the hatch on the International Space Station. The ground control team send a command for Dragon to undock from space station. It takes about 6 hours for Dragon, once it leaves the space station, to come home and splash down in the Atlantic Ocean.
The mission is not over until the astronauts land safely on the Earth. It's not until then that we can breathe a sigh of relief and call the mission a success.
We came out to see the splashdown as well and understand what the recovery team was going to go through, and so that was pretty exciting.
The recovery team is already waiting and ready to go get Dragon out of the water.
The 16 Draco thrusters are responsible for orienting the vehicle in the correct direction. They fire to slow the vehicle down to the point that it will come out of orbit and begin to re-enter the atmosphere.
Re-entry is one of the most dangerous points in the mission. There is no way to stop re-entry once it starts. All the SpaceX and NASA crews must wait and hope for the best. Traveling at about 17,000 miles per hour, when Dragon hits the atmosphere, its heat shield will be put to the test as the vehicle is enveloped in a giant hypersonic fireball.
The atmosphere does the majority of the work to slow the vehicle down to a few hundred miles per hour.
Dragon spacecraft is now subsonic.
Now that the heat shield has passed its test and Dragon has safely slowed to below the speed of sound, it's ready to deploy its parachutes, which is the final step of re-entry.
Parachutes are way harder than they look. If you go back and look at the Apollo program, they had people quitting over how hard the parachutes were. We almost had people quit at SpaceX over how hard the parachutes were.
When the capsule reaches the correct altitude, we will deploy the drogue parachutes. And then the main parachutes. To bring us to a jogging speed before we splash down in the water.
And there we have confirmation of splashdown.
We have a team of people on fast boats that go out and attach ropes to the spacecraft. They bring it over to the recovery boat. The recovery boat has a crane which lifts Dragon out of the water and onto the deck of the boat.
You know, the system is more than just the spacecraft. It's the people behind it that are operating it across teams.
Most importantly, we learned how we can keep the crew safe, keep them comfortable all the way through the journey, there and back.
It's a good confidence builder, not only for Bob and I, but for the team that you can do it again with the crewed vehicle.
To see it pulled off so successfully kind of really brought home kind of a ton of excitement for the mission that will be Demo 2, the first crewed mission.
SpaceX is focused on the future, reaching the next testing goal for launching crew. They don't have time to look back.
The reason I started SpaceX back in 2002 was really just to help us get to Mars. You know, I thought there was like maybe a 10% chance of success that SpaceX would work at all.
One path is we stay on Earth forever, and then there will be some eventual extinction event. The alternative is to become a spacefaring civilization and a multi-planet species, which I hope you would agree that is the right way to go. Yes?
Well, I'll tell you, there's a lot that makes Elon Musk unique. He's passionate for what he believes in. He's committed to what he's trying to achieve. He's willing to put his money where his mouth is and then achieve really stunning things.
Yeah. Elon Musk was born in South Africa and emigrated to Canada and then to the United States. He was one of the co-founders of PayPal, and that's how he made his millions. And after he made his money, he started thinking about what he wanted to do next and what he could do to help humanity. And space travel was, one of the ideas he had.
There's so many things that make people sad or depressed about the future, but I think becoming a spacefaring civilization is one of those things that makes you excited about the future.
You know, his vision at the time was just, we need to get the American public inspired to increase NASA's budget. That was his goal. And I'm like, hey, you and I have the same goal on that one.
This is under construction, but this is where our mission control and launch control will be. This is Gwen at her cube.
I joined SpaceX in September of 2002, and it was me and 10 other people.
SpaceX President and Chief Operating Officer Gwen Shotwell is a key member of the team.
Elon was very clear with everybody. We were to build the technology that was necessary to take people to live on other planets.
This is our engineering test article of our Dragon spacecraft. This area is used for the engine components.
There's a saying, the easiest way to become a millionaire in space is to start out as a billionaire.
He brought money, right? He brought the first $70 to $100 million to this company. And that was key because that allowed us some runway to demonstrate that this little group of folks could grow into a company and build the capabilities that no one thought we could.
He created, ultimately, Falcon 1 and Did 3 failed launches, stuck with it, went up to the edge.
Elon knew that he had to push the boundaries and create a superior rocket in order for SpaceX to thrive. But the company only had enough money to build and test 4 rockets. The first 3 Falcon rocket launches ended in disaster. The future of SpaceX looked bleak.
All right, welcome to SpaceX. Here we are in the lobby. I mean, the very early days, I'd have meetings with NASA and they were like, yeah, whatever, it's internet guy, PayPal, whatever. It's just some rich guy is gonna lose all his money and the rocket's not gonna work. Which is totally, fair. I mean, we hadn't proven anything, I hadn't proven anything.
In the early days, when SpaceX was first trying to get to orbit, they had a rocket called the Falcon 1, and they launched it 3 times. All 3 times were unsuccessful, and they had one more chance. The 4th flight of Falcon 1.
If it didn't work, then SpaceX would have gone bankrupt and we would not be around.
Stage separation confirmed.
Fortunately, Flight 4 did work.
The Falcon 1 rocket was a success. In 2008, SpaceX landed their first NASA contract. SpaceX was now officially in the space game.
NASA awarded contracts to SpaceX and then Orbital Sciences to fly cargo and supplies to the International Space Station.
NASA brought capital to the company at a time when it was absolutely critical for us.
Behind me is where Falcon 9 would sit during launch. And the big transformation that's going to occur over the next few months is the construction of the launch mount.
With NASA, we kind of initially got onto the Maverick section, or the highly unlikely to succeed, but we'll take a chance on them. But we were definitely not considered the 18, let me put it that way.
Under contracts with NASA, SpaceX has flown multiple cargo resupply missions to the International Space Station. But flying cargo was never the end game for SpaceX. Their goal has always been to fly people. It was the company's success with these prior programs that gave NASA the confidence to hire SpaceX to fly their astronauts for the Commercial Crew program.
We've had a long and very productive working relationship with NASA over time, gradually building up from these guys have no chance to, over the course of now 18 years, to the point where NASA has enough confidence that they're going to launch astronauts on the SpaceX vehicle. So that's it's a great honor.
Uh-oh.
It's teasing
totally
you.
Teasing you. That's the Three Stooges poke right there.
Yeah,
that is.
It's like the Mo version.
Doug Hurley and Bob Behnken are super experienced. They have many years behind them. They're 2 people who've been to space.
I did fly on the space shuttle previously. I flew a couple of missions. I went to space station, did a lot of assembly, spacewalks.
And there's Bob waving.
I flew on STS-135, the last shuttle flight, and then before that STS-127, which was an assembly flight.
We go pretty far back. We were hired in the same astronaut class back in 2000, so going on 2 decades, which is, I guess we're called maybe the senior astronauts at this point. And
old guys. Never flown in space together, and that's what's really exciting.
Bob and Doug actually met their wives in that same astronaut class. So they're both married to astronauts, and they both were even in each other's weddings.
That's Megan McArthur, who is our flight engineer.
Astronaut Karen Nyberg blasted off for her mission aboard the International Space Station.
Having spouses that are astronauts that have been through what we're going through, that kind of recognize that there's long days that are involved, and they appreciate that aspect of it.
Just make sure the backups are doing their job.
They're not all that bad.
They understand the ups and the downs, they understand the risks. It just makes it a lot easier in some respects, and maybe harder for them in some respects because they do understand all the risks and they've done it.
You left a 3-year-old son at home. You missed his first day, I think, at preschool.
Of course it's hard, but we do have great communication. My husband sends up pictures and videos.
We both have families that are pretty similar. We both have young boys that are in elementary school. They're both going to get a chance to really kind of see us flying in space for the first time. I'm really excited to be able to share this with my son. He understands that rockets are dangerous, and he first said, "You can't fly on that rocket." And we had to get him over kind of the, the emotion that goes along with riding on a rocket ship and getting him comfortable with that.
As we move towards flying, these two individuals, as we often refer to them as these two fathers, right? They're these two people who have families. It's something that we take very, very seriously. We want to make sure that everything we do is right and that we're going to bring them home safely.
Anytime you're developing new spacecraft, new technology, there's so much risk that's inherent in that. And when you put human beings on board, that makes the stakes so much higher. Everything has to go right for it to be a success.
In the nature of our business as military test pilot school graduates kind of going through what we've been through, we recognize that there are all aspects of risk associated with our missions or the tests that lead up to it.
It's a scary thing to be launching people, and risk is never zero.
SpaceX's success record is far from perfect.
3, 2, 1. Liftoff of the SpaceX Falcon 9 rocket.
On June 28, 2015, SpaceX launched their 7th cargo resupply mission for NASA to the International Space Station.
And we appear to have had a launch vehicle failure.
Several minutes into launch, the Falcon 9 rocket failed and completely disintegrated, destroying the entire contents of NASA's cargo.
It's definitely, a setback, but the fact of the matter is rockets are just extremely difficult.
It was later determined that the failure was likely caused by a single strut inside the rocket that broke free and breached a helium tank. Then, on September 1st, 2016, another major failure. The SpaceX Falcon 9 rocket that was supposed to launch a communication satellite blew up during a test fire.
It's part of testing. These things do happen, and the thing you want to obviously avoid is when people are on that vehicle, you don't want those things to happen. So that's why you test, and SpaceX really wants to test things to their full capability, and sometimes things do blow up.
Neither of these missions were intended to carry humans. This is why the next failure SpaceX encountered would be their most difficult. During a test fire of the engines, the very same Dragon capsule that was used in the Demo 1 mission was completely destroyed.
They lost the entire Dragon capsule, which was a huge setback for them. And it raised some real concerns.
When the Dragon capsule was lost, we go through that range of emotions. First, you're going to have to deal with questions from your family, and folks are like, "Hey, is that the vehicle you're going to ride on?" How do you manage, telling your son that you're facing that risk as you go forward? That's a thing we have to do.
This was a moment where inside NASA, I think people were wondering, was this whole experiment going to work?
We experienced an anomaly on the test stand where our Crew Dragon vehicle from the uncrewed test flight exploded.
There were people on the beaches of the Florida Space Coast, and all of a sudden, they saw this huge plume of orange smoke go up.
It's an interesting challenge to figure out how, for a kindergartner, that's the age of my son, how do you explain, the situation that kind of unfolded? Luckily, he's not on the internet to be able to chase down those videos on his own at his age. But we went through the process of taking him to Florida, watching a rocket launch. So after going to Florida, seeing a new ship kind of launch into space, he was ready for me to go.
And I think going along with that, not only kind of reinforcing some things to your family, but reinforcing things with the team. We kind of felt like in some ways we had to kind of get the team back up, especially the team in Florida, because obviously they took it very, very hard and very seriously.
They recognize that they're responsible for our safety kind of going forward. So it's pretty hard on that team to look us in the eye after having, a failure like that.
Right after the explosion, NASA and SpaceX led an investigation. They quickly found the root cause of the problem.
The SpaceX investigation revealed that the cause of the explosion was an unexpected reaction between a fluid under high pressure and a titanium component inside the vehicle.
The anomaly we had the capsule strapped down to a stand, and we had a large series of high-speed cameras and tons of sensors, which allowed us to really get to the root cause of a very nuanced risk that we would not have otherwise known about.
From an engineering perspective, this was actually a success. We identified a new failure, and we're actually making our vehicle safer. We're making the whole industry safer with this new understanding.
I'm very proud of the SpaceX team, and in fact, it just came from a Dragon engineering review. We went through a detailed list of all the risks, and I think that the Dragon engineering team has done a great job working closely with NASA, and also we're just going through and double-checking everything to make sure that things are as reliable and as safe as possible.
How does a test pilot kind of prepare for a first flight in a spaceship? That's a great question, because the last time we did this in an orbital vehicle, it was John Young and Bob Crippen. So it's been a while.
We usually ask, what if it doesn't go exactly the way you planned? Then how should we be prepared? And so we really try to dig into every piece of the puzzle to really understand what's our plan and then what's our backup plan. And we're prepared for all of those things.
NASA and SpaceX must prepare for all potential problems. If there's a fire on the pad, the astronauts must escape quickly. So they train on emergency escape systems.
SpaceX has on Launch Pad 39A an emergency egress apparatus. If there's a fuel leak or the astronauts need to get off that launch tower as quickly as possible. So they've set up essentially a giant zip line.
From 265 feet above the ground, the slide wire basket whisks the astronauts down the line in under 30 seconds to a distance of approximately 1,200 feet from the pad.
There are armored vehicles waiting for them that they can get into and then be escorted away to safety.
The launch pad isn't the only place where astronauts face potential danger. If there are rough seas or storms, the capsule's splashdown in the ocean would present a challenging rescue.
The water egress test is where we practice getting crew members out of the capsule when it's floating in the water in an emergency situation.
Landing in the water, anybody who's been on a deep sea fishing trip knows that you can get pretty seasick pretty quickly, having not even been to space. So landing in the water is somewhat of a challenge with the physiological aspect. So we'll see how we react.
When the astronauts come back from space, they'll land in water. We will pull them onto our recovery ship, and the first thing we do is I'll enter the capsule and I will make sure that they're healthy, decide how they need to be brought out of there. We want to make sure that we move them really slowly to keep them from being sick, and we'll do a lot of things to keep them comfortable when they return.
This is what we do as astronauts. This is what we do as test pilots, you know, and the opportunity to be able to go fly this vehicle for the first time with crew is just something you could never pass up. When we go to test pilot school, this is the kind of thing that you wouldn't even imagine you to get a chance to do. It's almost a once-in-a-generational opportunity.
How's it going?
Hey, Bob.
Good to see you. Good to see you. Hey.
Doug, good to see you.
In 2014, the Commercial Crew Program awarded SpaceX $2.6 billion to create a new launch system. Today, NASA Administrator Jim Bridentstine is visiting the SpaceX factory to see how the taxpayers' money is being used.
A lot to see, huh?
Yeah.
The SpaceX factory is like a candy land for aerospace. It's like this incredible place because you can see rockets being built, lots of rockets. You can see lots of engines being built. You can see Dragon spacecraft being built. You can really see the cutting edge future of spaceflight all the time, all around you.
This is the non-flattering part where you gotta look like an Oompa Loompa to see the cool stuff. Dragon 2 has almost exclusively SpaceX components and valves on it, with a few exceptions. So we have in-house control of all that, stays all in the same clean room and building, and we're able to really stay tightly integrated and move fast.
Yeah, good.
SpaceX is unique in that we manufacture and assemble nearly the entire launch vehicle and spacecraft, in fact, in the same facility. And other companies do operate differently. They will contract out the fabrication of assemblies, and so that's a really unique approach in the aerospace industry, where we have the engineers designing the parts right next to where they're getting built. And so SpaceX is able to develop and fabricate and test hardware faster than perhaps anyone else in the industry because of our vertically integrated team and production system.
NASA has a long history and a legacy of spaceflight. SpaceX is kind of a newcomer to the industry. They come from Silicon Valley. They have a different mindset. They like to fly, test, and then fix. Fly, test, and fix, which is very different than the historical NASA way of doing things.
Maybe the biggest difference between SpaceX and NASA is that traditionally at NASA and a lot of aerospace is that you did this sort of serial approach where you do some amount of design and development, a little bit of testing, you're doing a lot of analysis, you kind of do this whole thing in serial. Whereas at SpaceX, we produce a lot of hardware and we test it and test it and test it rapidly. That allows us to do a kind of parallel approach where we're doing design and test at the same time. It allows us to go faster.
I don't think everyone at NASA could have worked with us in the 2006-2007 timeframe. I'm sure they referred to us as the Wild West or these crazy people out there in Los Angeles. You know, that's not a way that the government worked. They decide what they want and they put a ton of documents together and say, build this thing. And we would push back on requirements.
NASA has always required that every nut and bolt of a new spacecraft pass a series of tests called qualifications before assembly and flight. But SpaceX has argued that testing the fully assembled spacecraft over and over again is equally effective.
It's not always been easy. I'll tell you, NASA has come to accept some realities that we can actually trade the qualification of every component and every subcomponent for flight experience. If you have 50 successful launches, you can trade the qualification of every subcomponent for those 50 launches.
We have flown the rocket many times before, not far from 100 launches, really.
It's been a challenge, I think, for the culture of NASA, but I think we've evolved to it. And I think it's made NASA better. And I think in many ways it's made SpaceX a lot better.
So I think NASA learned how to push back requirements from us. I always refer to my employees as being mouthy. It's good to have mouthy employees. And I think NASA probably learned how to be mouthy by working with SpaceX.
This is the part of the factory that houses the revolutionary Falcon 9 rocket.
This rocket essentially has been designed with the help of NASA, with the help of the Air Force. It's really designed for how to make the most reliable rocket ever made. Right. So that is the fundamental goal.
Right.
Falcon 9 is essentially standing on the shoulders of titans, as they like to say in literature. We've built upon a lot of those lessons, the things that NASA has learned. We've taken that, but used kind of a clean sheet of paper that says, how can you build a rocket knowing that we want to do things that have not been done before?
In the history of spaceflight, rockets were used once.
Liftoff of the Atlas V.
Their first stages went up, delivered their payload to space,
We have stage separation.
Then they splash down in the ocean, never to be used again. That would be like flying cross-country from New York to LA and throwing away the airplane. That would make commercial aviation enormously expensive, and yet that's what we've been doing in space.
We have liftoff of the Falcon 9.
What SpaceX has done is developed a rocket that can be reused. Its first stage booster delivers its payload to orbit.
Stage separation confirmed.
Then it flies back and lands on land or at a ship at sea.
We have an interesting history at SpaceX when we talk about failure.
SpaceX knows that failure is an unavoidable stop on the path to success. Now that they are on the verge of flying astronauts for the first time, the stakes have never been higher.
Also, the boost stage of Falcon 9, because it's designed to be returned, this stage is insanely robust. It's really gone through its paces.
Yeah. The Falcon 9 is a huge step forward in spaceflight and achieving the goals of SpaceX and ultimately making life multiplanetary and lowering the cost of space. The biggest achievement is the ability to return the Falcon home, to land it. And so it is hard. It's definitely hard to do.
You need to be able to accept failure during the design, the innovation process here at SpaceX. And a lot of times in the rocket business, failing means you're making craters. There's a smoking hole in the earth somewhere where a great idea came up a little bit short and it crashed into the earth. During the test phase, we would get close to the ship, but we may be going sideways. We ran out of propellant. But we do that because you use a test, a fly, a test, a fly, and then figure out how it works. Not necessarily by just running analysis in computers, but by actually flying the rocket. That's where you really learn what the rocket can do.
For decades, honestly, people thought that that was not something that you could do. They thought it would just be too hard to bring a launch vehicle back, to control that vehicle coming all the way back to Earth.
After years of designing and testing the Falcon 9, in 2015, SpaceX set out to make history by attempting the first ever landing of a first stage orbital rocket.
Stage separation confirmed.
To bring Falcon 9 back to Earth, we've got a navigation system in the first stage. Most first stages don't have that. The rocket will then relight 3 of the 9 engines to begin to slow down. Each engine can be moved left and right, up and down, so that we can steer the rocket back towards where the landing site's going to be.
Stage 1 landing burn has started.
I've heard it described as you're standing on the top of the Empire State Building and you drop a pencil off and you have to land the pencil on its eraser on a postage stamp. Ultimately, it's not beyond the realm of physics. And if it's not beyond the realm of physics, there's an engineering way to get it done.
The Falcon has landed.
Wow, this thing actually landed intact and amazing. That was crazy.
There's an old phrase, if you're not failing, you're not learning. So if you're too cautious and you never fail, you're not actually figuring out how to push the envelope to do the kind of things that no one has done before.
You know, there were a lot of people that didn't think the rocket landings were real. They claimed that we were just like running the video in reverse. Sometimes people like get confused between improbable and impossible. There's lots of things that are improbable. But unless you break the laws of physics, it's not impossible.
Currently, the Falcon 9 is designed to be flown 10 times. Each time we do a refurbishment, what we call vehicle maintenance. That doesn't mean that it expires after 10 flights. Instead, as we get close, we will look to do some more testing because we expect the Falcon 9s can fly way more than 10 flights. We just ease up on it a step at a time as we expand the history.
This is Launch Complex 39A at Cape Canaveral on Kennedy Space Center. This building houses and processes Falcon 9s that have landed at our landing pads or have been landed on the drone ships and have come into port. To refurbish a rocket, they roll into the hangar, we load them into their processing rings, and it's a matter of weeks to process them and get ready for launch. Reusability is incredibly important to space exploration. One, it helps with cost savings, and two, it helps with time. If every time you had to build a new vehicle, we would be waiting and waiting and waiting for a new rocket to be produced. But when we're able to fly rockets, land them, and reuse them, that means we can access space on a weekly basis versus like a monthly or yearly basis. The end goal is obviously to have zero refurbishment, to be able to land and then relaunch like airplanes, to ensure that we're able to access space on a daily basis. That's something that SpaceX is very proud of and what we're trying to do as a stepping stone to help us to get to Mars.
Normally the stages, they basically just crash in the ocean.
Yeah.
You can't recover the hardware, so you can't see where there was a close call.
Right.
When we get the vehicle back, we examine the vehicle and physically see, was there anything that potentially had a burn through or where we were close on margins.
Right.
And then we can adjust that in the design.
Well, what we're seeing, when you use the same rocket the second, third, fourth, fifth time, insurance rates actually go down, not up.
That's how you can tell. Like,
yeah.
the insurance company's pretty sharp.
Right.
And, like, they don't like losing money.
Right.
After you get through that first flight, just like a commercial airplane, you like an airplane that you know has been flown several times rather than being the first customer on board the airplane.
The commercial insurance rate is the best indicator of the reliability of a rocket.
Right.
And we have the best insurance rates in the world.
Oh, is that right?
Yeah.
I didn't know that.
The Holy Grail is really a fully reusable orbital system, by far the most important thing. It's like the difference between having aircraft that are reusable or not, or cars. The profundity of this is not well understood by very many people.
Team SpaceX still has one more critical test to pass before they will be allowed to fly NASA astronauts. What happens if a rocket explodes in flight? There is a plan to save the crew.
3,
SpaceX
2,
now must prove
1,
that it works.
launch.
The Crew Dragon capsule is the spacecraft that houses the crew. It is replacing the Cargo Dragon capsule that was previously used on SpaceX resupply missions to the International Space Station.
The Dragon spacecraft that we'll be using to carry astronauts to the space station and bring them home is really a 21st century spaceship.
My first impression of the inside of Crew Dragon, I was amazed. It's obviously a modern space vehicle. It's a very sleek design inside, very comfortable. The seats are actually car racing seats, so the safety factors go up considerably.
We've flown Crew Dragon already to the space station and back. We subsequently made a lot of changes, improvements, but we also just have to be absolutely paranoid about safety.
This is a fully flight-like, fully functional suit.
The first time I was in one of these was probably almost 4 years ago, testing out the suits and seeing what works and what doesn't.
The suit's been in development for over 5 years. We've had the chance to work with Bob and Doug in the development of the suit.
It's been a huge undertaking to build their suits, a huge undertaking.
Yeah.
I can't understate that.
Right.
Absolutely. Building a spacesuit is not easy.
The astronauts as a group have been part of our design process, part of our test and training process from the very beginning.
So the idea is, as long as the spacecraft is pressurized, this would be not inflated, correct? It would be depressurized. If there's a loss of pressurization, this inflates.
Yeah. It does look funny deflated, though. Maybe we should like pop it up a little.
All the spacesuits that we wear as astronauts have a very specific design that they're trying to accomplish. And so the Dragon spacesuit is really to protect you from a depressurization or to make sure that if something was wrong with the environment, a fire with smoke, and you needed air to breathe. And so that spacesuit is not to do spacewalks. That spacesuit is not to do a lot of other things. It's to protect you in the event that something's wrong with the rest of the capsule's atmosphere. That spacesuit is your little capsule that you can go inside and kind of hibernate in to finish out the mission.
It's a chance to survive and get to the ground.
In the unlikely event that the vehicle develops a leak, like that in-flight warning, you could fly an airplane. In the unlikely event that the Dragon develops a leak, we actually do have oxygen nitrogen on board, and we can replenish the leak
I mean, basically, if the leak's really big,
Right,
you just
yeah.
got hit by a meteor.
Right.
It's like, yeah, you got
Yeah.
any kind of not crazy leak, like anything besides a gaping hole.
Yeah.
Once you're fully pressurized, you're not going to be able to do much.
Just because it's so rigid?
Yeah, it's rigid and you're the Stay Puft Marshmallow Man.
Right.
You can move when the suit is pressurized. It just requires you have to exert.
You get tired.
You're tired. That's the
Pressure suits are a bit cumbersome. Even these pressure suits, albeit are a lot more comfortable and a lot lighter, a lot easier to get in and out of than the AAC suits we wore on shuttle. They're still a suit that you have to contend with.
So this is a single-piece suit, so everything's attached: gloves, helmets, boots. That's just to try to keep it as simple as possible.
Yeah.
Some of the new advancements, I think the first thing a lot of people notice is the helmet. The helmet is 3D printed, and that gives us a lot of flexibility in terms of the features that we can model in the helmet and things that we can include inside of it. There's been developments on the materials that we use on the suit. The outer materials are for flame resistance, so primarily PTFE or Teflon fabric, and then the grays are Nomex material.
In terms of designing the spacesuit, some of the concerns that come from the medical side are, what are the levels of CO2 that builds up in that suit? How do we provide oxygen and cooling to that suit?
This here is routing all the time to keep the crew cool, so you can see there's actually like a tube network running. These tubes to the feet, there's similar tubes to the wrists, and then 2 to the neck as well, so that we get a lot of cooling for them.
We look at, from the medical side, how do we keep this human being comfortable and healthy? And Chris and his engineering team looks at how to build something that's unique and capable of doing that in a brilliant way like he's done. Awesome. Well, thank you, guys.
Well, the experience of training in an accurate capsule with a spacesuit is invaluable.
Bob and Doug wore their spacesuits in the simulation because we want training to be as flight-like as possible for them.
SpaceX Dragon, we are ready to pressurize.
When you have all your equipment on, it allows you to get more comfortable in a situation. So the more you can train in those suits, the better you'll be on the real day.
It's exciting to see, modern components in a spacecraft.
You get very used to the shuttle, the 2,000 switches, circuit breakers, the seats. It's not the most comfortable vehicle to fly in.
For those of us who've been living with switches from the 60s for all these years, to see a modern interface is something that's pretty exciting.
SpaceX Dragon, we've got 2 good LEDs.
Copy all, Dragon. Some of the great innovations that we've made, we have these wonderful touch screens, so you can see everything that's going on in the vehicle. You can get all the data that you need about the vehicle, and you can also control the vehicle all from these touch screens.
The gloves are compatible with the touchscreen. It's imperative because there are operations you need to do with the gloves on.
Our tablets are updated.
The Dragon capsule is almost completely automated, so it should be able to fly the entire flight without us intervening at all if everything goes normally. And I think it's the way of the future with vehicles. I mean, we see that now with cars, we see it with airplanes, and this is just the next logical step.
You should monitor your Dragon longitude for knowledge about initiation of claw separation prep.
When you think about automation, it's a layer of complexity in software that needs to be verified. So the task for crew on a good day is hopefully that they don't need to do much. On a bad day, they need to understand exactly when and how they need to respond to the vehicle's behavior and what it's doing.
Dragon SpaceX com check.
SpaceX Dragon, we've got you loud and clear.
Every single phase of the mission will be simulated. So we have launch sims, we have approach to station, entry, descent, and landing. And every single phase has failures that are unique to that phase and require different responses.
Dragon, we are going to step into the scenario. Ultimately, even though it's able to autonomously fly, we want to make sure that the crew understands what's happening and that they can take control at any point in time to ensure that their own safety as well.
We can manually intervene if we think things are not going the way they should be with the automation.
Dragon SpaceX for a flight computer.
Yeah, looks like we lost it.
Today, the astronauts are training for a scenario in which the flight computers fail. Since the Dragon crew capsule is totally automated, it relies on the computers for almost everything. With the computers down, this could be a dangerous situation for the astronauts.
We see one of your flight computer processes are not controlling the vehicle.
So what we'll do in training is we break Dragon.
Dragon SpaceX, please proceed to reboot flight computers.
So if the flight computer goes down, we teach them how to reboot it.
Okay, we've initiated the flight computer reboot.
And we see the same on the ground. We're following that. Thanks.
During simulations, you'll see a lot of anomalies, malfunctions. Sarah and some of our other simulation supervisors, they relish those opportunities.
The deorbit burn has been interrupted. We are investigating the root cause on the ground.
Dragon copies.
It's really good not only for Bob and I as the crew, but it's also for the team on the ground. It really throws the team different curveballs.
Flight computer has transitioned to deorbit burn.
We show all our displays back up.
And that's great news.
Splashdown.
Victory.
NASA has required that SpaceX's design of the Crew Dragon capsule has a significantly higher level of safety than its predecessor, the Space Shuttle.
Every aspect of Dragon has been tested at the subsystem level, as an entire vehicle. There's so many tests, it would blow your mind.
Even with all the safety features that SpaceX has built into their systems, NASA is also requiring the inclusion of a revolutionary new safety feature called the Launch Escape System.
If there was an emergency on the pad, the capsule is able to separate from the Falcon rocket, and that's done to protect the crew.
Our launch escape system is essentially an ejection seat for the entire spacecraft. If the computers sense a problem with the rocket, the spacecraft will automatically separate itself and fly through the air with its Super Draco engines so that it can safely splash down in the ocean with its parachutes and save the crew from an in-flight anomaly. The Crew Dragon spacecraft has two types of engines on board. The first are 16 Draco thrusters. Those are small engines that make about 100 pounds of thrust. And those engines are what we're going to use to maneuver and dock to the International Space Station. And then there are the 8 Super Draco engines for a launch escape scenario in an emergency situation, which make thousands of pounds of thrust. Crew Dragon is utilizing 3D printing to manufacture some of the components on it. A 3D printer works by laying down layers of metal powder, and as it lays down each layer, it will melt together a specific part, and then it builds up layer by layer to create whatever shape that you want. And so this is really useful when we look at things like printing an engine that needs many fluid passages in it. It needs to be a very interesting organic shape. And because you melt it together layer by layer, you can make hollow parts, you can make very interesting shapes that would be difficult to make by any other method.
In 2015, SpaceX performed a preliminary pad abort test of their launch escape system.
Our pad abort test was performed to ensure that our spacecraft design could escape the launch pad safely to the water in the event of an emergency.
3, 2, 1, launch.
During an escape, they will likely pull between 4 and 6 Gs. It depends on the different variables and the situation. I think a roller coaster is under 3 Gs.
We're over 1 kilometer. Truck deploy. Drugs look good. Passing through 600 meters.
The pad abort test was a precursor to a much larger challenge called the in-flight abort test.
In-flight abort is a similar test, but it tests a different set of conditions. Instead of demonstrating separation from a rocket on the launch pad, the in-flight abort test will demonstrate separation from a rocket that is actively flying through the atmosphere. If there's a problem with the rocket, the in-flight abort test will show how the capsule can eject itself from the rocket and safely bring the crew down to the water.
4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
One of my strongest memories as a child was in 5th grade. We watched the Space Shuttle Challenger blow up. A loss of the entire crew was a result of the fact that there was no launch abort system. It shuts down the program for a period of years. What we want to do now is we want to get to a day where when there is a catastrophic failure, we have a launch abort system that keeps our crew safe.
Good afternoon, and thank you for joining us. We're here today to talk more about the SpaceX in-flight abort test.
It's a demonstration mission for SpaceX to show that we're able to eject our capsule off of Falcon 9 safely and reliably.
This test is very important to us. It's really the culmination of years of close partnership with NASA, and it's one of the key steps before we go to our Demonstration 2 mission, which will carry Bob and Doug up to the space station.
SpaceX must pass this critical in-flight abort test before NASA will allow them to fly their astronauts. Soon, human lives will be at stake, so every precaution must be taken.
The plan will be that Dragon is on top of the rocket. The rocket will take off. At about 84 seconds into launch, we'll trigger the launch escape system. Then Dragon will carry the capsule safely away from the Falcon. Dragon will hit about Mach 2.3 as it's getting away. It will then hit an apogee of about 40 kilometers high. It'll jettison the trunk. It'll reorient itself with the Draco engines, and then it'll continue its trajectory down. And about 5 minutes after launch, the parachutes will deploy. And about 10 minutes after launch, we expect splashdown. The Dragon recovery forces will also be out there. One of the things I want to mention, and this is kind of exciting, the Falcon has flown 3 times before, and it's going to refly for this test for the Commercial Crew Program.
The booster behind us, or the Falcon 9 behind us, will be flying our in-flight abort, so this will be its 4th flight.
To my knowledge, the in-flight abort test is the first ever full-scale launch escape system safety test. In the past, other crewed programs, they've done subscale testing. This is the first time I think someone has ever taken a rocket and intentionally thrown it away with the sole focus on ensuring that the system they're designing to ensure the crew is safe will actually function as expected.
A big part of the cost of the in-flight abort test will be a multi-million-dollar rocket that will be deliberately and completely destroyed in the test.
Hi, Chris Davenport from the Washington Post. Question about the fate of your booster. You said it could tumble, it might come apart, you mentioned a fire. I mean, is there a possibility that it could actually explode if people are watching, from the beach? Should they be prepared for that? Thanks.
Sure. Absolutely, Chris. Yes, both stages are loaded with fuel. We expect there to be some sort of ignition and probably a fireball of some kind. Whether I would call it an explosion that you would see from the ground, I don't know. We'll have to see what actually happens. But I wouldn't be surprised, and that wouldn't be a bad outcome if that's what we saw.
While you hope the abort engines never light, you don't want that ever to happen, because that means something very, very bad has happened. You're in an emergency situation, but it can happen. I mean, just recently, NASA astronaut Nick Hague was on a Russian Soyuz where there was a problem with the rocket. The Soyuz spacecraft's emergency abort systems lit, and it ferried them to safety. Now, it was a wild ride, and they pulled something like 7 Gs or 7 times the force of gravity on their body. It was not a comfortable experience, but they were alive and they landed safely, and that abort system saved their lives. The in-flight abort test, if you're Doug and Bob, that's immensely important because it just reassures them that the spacecraft they're going to get on is safe.
Key NASA and SpaceX officials have gathered in Firing Room 4, also known as Launch Control, at the Kennedy Space Center. They will oversee today's critical in-flight abort test. If this test fails, the Crew Dragon program will suffer a major design setback.
We're obviously doing everything we can to make this mission as reliable as possible. No stone is left unturned. We're turning every stone over 3 times or 4 times just to get that probability of success as close to 100% as possible.
This test is about the entire team, the NASA team, the SpaceX team coming together and pulling off a pretty complex exercise, right? We're going to launch a capsule, we're going to put it in the ocean. Department of Defense is going to have coordination required between NASA and SpaceX, and that entire team is going to show that they can bring a capsule home safely, bring the crew, if they were on board, home safely. And so that's really what we're expecting to see out of this test.
Weather's looking okay, and the range is green for launch.
Dragon is in countdown. FTS is armed. Go for launch.
10, 9, 8.
If the test isn't successful for some reason, of course, you have a whole group of folks both on the SpaceX and NASA side that will have to take a look at things and figure out why it wasn't successful. And this is obviously something close to the last step. This is all part of building up to flying crew on Dragon.
7, 6.
When you watch a launch abort test, you're wondering, has everything been done to get this vehicle ready for an end-to-end test in one of the most stressful and dynamic scenarios you can imagine for spaceflight?
5, 4, 3, 2, 1, 0. Ignition, liftoff. Super 5 aim high. Go Falcon, go Dragon.
This potentially life-saving capsule ejection has been years in the making, and it will be over in just minutes.
Rockets it's basically a controlled explosion that's pushing a mass into orbit at faster and faster speeds. And it's the most dangerous part of getting anything to orbit. And so to simulate a failure of the thing that is most likely to fail, the rocket, and demonstrate that the capsule with the precious cargo that's sitting in that capsule can survive that, so key.
SpaceX has launched a Falcon 9 rocket and Crew Dragon capsule. The abort is automatically activated when the system detects that the rocket is malfunctioning, such as in the case of an engine failure, explosion, or the rocket veering off course. The abort can also be manually triggered by ground control. That will happen in this test.
Vehicle is supersonic and passing through maximum dynamic pressure.
Once the computer senses that the rocket has malfunctioned, it blows the bolts holding the capsule to the rocket.
Dragon launch escape initiated.
Then, the Crew Dragon's Super Draco engines fire for 10 seconds to propel the capsule away to safety.
Dragon's away.
Whoa. Because the Super Draco escape thrusters are integrated into the vehicle, you have a launch escape capability all the way to orbit, which has never been the case for any spacecraft before.
Approximately 10 seconds after the abort was triggered by ground control, the Crew Dragon capsule jettisoned away. The force of the ejection made the rocket unstable, and it exploded. But the Dragon capsule was already safely a mile away from the rocket. With the Dragon jettisoned safely away, the trunk, which carries unpressurized cargo, is ejected and will crash into the ocean. Now, the capsule will begin to reorient itself for splashdown. However, the mission is not over. With the capsule hitting a top speed of Mach 2, this last phase is key for the astronauts' safety.
Oh, drones! Our parachutes are triggered and deployed when the capsule reaches the correct altitude. And so at a high altitude, it will deploy the drogue parachutes. And when it reaches a lower altitude, the main parachutes will deploy.
Fully open, and we are coming up on about a minute until splashdown.
All right, it's coming down. Perfect. Splashdown.
To watch it go from start to end successfully, it just it's really something to behold. And I know A lot of emotions on both teams today, and we're very excited about it.
It's just one step on this longer road to creating a mass transit system for people to other planets.
Is everything good?
Everything's good.
So as a crew member that's going to ride on board this vehicle, having a system on board Dragon that can get you out is pretty cool.
I think people sometimes forget like that technology does not automatically improve. It only improves if a lot of people work very hard on that technology. We have to drive innovation hard to make life multiplanetary. I think this is very important to secure the future of life as we know it, and to ensure that the light of consciousness does not go out.
We are a nation of explorers. We're also a nation that leads. And this, of course, represents us returning American astronauts to space on American rockets from American soil. So this is a great opportunity for us to once again lead. And this time when we lead, we're doing it differently than we've ever done it before. We need to make sure that we are constantly pushing the envelope, constantly moving forward with technology, and making sure that we are commercializing it in the process. Today we had a launch abort test of a commercial crew provider. Commercialization of space is the next giant leap. And when we take this leap, we absolutely need to make sure that our crew is safe.
The success of today's in-flight abort test sets the stage to send astronauts to space from U.S. soil once again, in a mission called Demo 2. And for the first time, they'll fly aboard a private spacecraft.
So in this very challenging time, when we launch to the International Space Station, something we haven't done from American soil since 2011, I do think that it gives people an opportunity to dream big and to look up and to know that we can do stunning things. And it gives people hope, not just in the United States of America, but throughout the entire world.
I don't generally get nervous, but when I start thinking about this mission, I actually get quite nervous about it. The launch of Demo 2 will be the day. This will be the moment for this company. This is the culmination of everything we have done since the company was founded in 2002.
This is a crucial step, getting people back to orbit again. You know, knock on wood, I think probably success is high, but it is not 100%. We're just doing everything we can to think of any possible way to improve the probability of success, because this would be a big setback if something were to go wrong.
Bob and Doug are poised to leave quarantine and ride in Teslas to iconic Pad 39A at Kennedy Space Center in Cape Canaveral, Florida.
We're excited, of course, for the mission, and one of our goals is to share it with everybody.
I hope that people appreciate the amount of effort done by so many people at NASA and so many people at SpaceX to get us to this point.
When Bob and Doug walk down the crew access arm to the Dragon capsule, they'll also be walking into the history books as the two astronauts that returned America to space from U.S. soil. This will be a stunning achievement for NASA and SpaceX, officially launching the second golden age of space travel. This is but the first step on a long journey that will take us back to the moon, then to Mars, and beyond.